These things would be enough. So we have found out the resultant, and we have also found out the subtraction of vectors. Now let us understand product of the vectors, right? So what happens when we multiply two vectors? But before we do that, yeah, there's one also very important thing. So there is this rectangular coordinates. So what we can do is that if we have some complicated questions, right? If we have some complicated questions in which we cannot find the resultant in a simpler manner, right? Then we use the idea of a resolution of vectors. So this is very, very, very important, right? So this is called a resolution of vectors. Right, so we have the coordinates, right? We have these coordinates, and so we have this x coordinate and we have this y coordinate. We are talking about rectangular coordinates, right?
Yes,
Rectangular coordinates meaning we have x and y coordinates, right? So we have rectangular coordinates. And we can write any vector if we know the angle it is making with the x-axis, and we know what is the magnitude of this thing. So we know what is the magnitude A and what is theta. So where A is magnitude of vector A, theta is angle with x-axis. Then we can write any vector in the form of the Cartesian coordinates, right? So how we can do that? So let's say we have this vector, right? This is magnitude is A. Its magnitude is A, and I know that what is the angle it is making with this thing. So what I can do is that I can find out the two components, right? This magnitude is A. So this would be the y component, and this would be the x component, right? And y component is what? Y component is A sine theta, and x component is A cos theta, right? So I can write any vector in the form of the Cartesian coordinate. So what is the Cartesian coordinates? This is AXI and AYJ. But I know what is this AX, AY in terms of A and theta. So AX is how much? AX is A cos theta, I hat, and AY is A sine theta, J. So this is vector A. And I can write any vector using this idea. So this is called resolution of vectors.
Okay, sir.
Right.
Yes, sir.
And using the resolution of vectors, we can write any vector in the form of I and J. So this helps a lot, right? This is a very useful trick to find out the resultant of different vectors, right? So this is a very important relation. And we have to be very, yeah, so if we can understand this, then it makes our calculation very easy. So what I will do is that, yeah, first you note it down and then we'll do a couple of questions. And yeah, so this is also called, AX is also called the horizontal part.
Yes, sir.
And this is also called the vertical part. right? So quickly note this thing down, and we will do a couple of questions from using this idea, right?
Yeah, okay, sir.
Whenever you have noted, please tell.
Okay, sir.
Yeah, whenever you have noted, please tell.
Okay. We can continue, sir.
Okay, so now let us do a couple of questions to understand. This relation is very important, right? So,
Yes, sir.
yeah, so the questions are, let's say you have a vector, right? You have this vector. It is, let's say, magnitude, or we can write this force as F. So this is some force, right? This is some force which is 4 Newton. This is 4 Newton force, and it is making an angle, let's say 30 degree with the x-axis, right? Then
Yes, sir.
how can we write this vector in the Cartesian form? How can we write this? So we know that x component, that would be how much? How much would be the x component? Can you tell me?
Um, it's cos theta.
Yeah, so 4 cos theta, right?
Yes, sir. For cos
And
theta.
4 cos 30. So, and then we have y component ay. This is 4 sine 30, right? Good.
Yes, sir.
So we have ax, which is 4 cos 30, which is 4 root 3 by 2, so which is 2 root 3. And then we have ay, which is 4 sine 30. So this is 4 1 by 2, which is 2. So I can write this vector. Let's say I can write this force. So I can write this, let's say, name it force or whatever. So this is ax I hat plus ay j hat. And what is this thing? So this is 2 root 3 I hat plus 2 j hat. So this is my vector, right?
Yes, sir.
And similarly, let's say I have another vector which is like this. So I have another vector which is this one, but this is given. Let's say this is 30 degree. But the angle, we always take the angle with which axis.
X-axis.
So with the from the x, let's say this is 5 Newton. So from x-axis, what would be the angle?
Be 62.
60 degree, right? So this is 60 degree. And again, we can write the x component as 5 cos 60. And y component is 5 sine 60. So ax is 5 cos 60. And this is 5 by 2. Ay is 5 sine 60. So 5 root 3 by 2. So I can write this vector as 5 by 2 I hat directly and 5 root 3 by 2 j hat. So this is the vector, right?
Yes, sir.
Now, let's say complicate this thing further. So I have this vector which is like this, right? I have this vector. And from the x-axis, it is making, let's say, 30 degrees. This is again 4 Newton force. And this is x and this is y-axis, right? So
Yes,
please
sir.
tell me what would be the vector. Please tell me what would be the vector.
Um,
Okay, I'll ask the question later, but let's solve this thing, right? So I'll ask the question later. First, let us write this thing, right? So x component, right? This would be x component, that would be 4 cos 30, and y component, that is 4 sin 30, right? So ax is 4 cos 30, which is 4 root 3 by 2. So this is 2 root 3. And ay is 4 sin 30, and this is 4 by 2. So that is 2. But but there's a trick to this question, right? So
yes, sir.
when we write the vector and ax is there, but the direction is not I hat. What is the direction for this x component? So this vector
G.
has this component, right?
Yes, sir.
We are only talking about x and y coordinate, right? So we don't have, oh, so you're saying j. No, x component is always x, right?
Yes,
This
sir.
is x component, so it can't be g. It will always be I. But you see that this is not in the right direction. This is in the left. So that would be minus I. Clear?
Yes, sir.
And then this is ay. And this is again g or minus j?
It's minus G.
Minus j. So this is minus j. So the vector that is representing this thing, that would be minus 2 root 3 I hat minus 2 g hat. Right? So this would be the correct representation of this vector. So we have represented this vector in this form, right? So you note down this thing and then we'll see that what is the purpose, what is the use of this thing. So there's a very important thing, even we will do the superposition principle of the forces. So this would come very handy. So please note down this. Okay, this part we have noted. Note down this thing.
Okay, sir.
Yeah, whenever you have noted, please tell us.
Okay, sir.
And we will see that what is the use of this resolution of vector. What is the use, right? Because if this doesn't have any purpose, then what's the use, right? Why do we learn this? So you'll see that it has a
Yes,
very,
sir.
yeah, it has a very important outcome. So whenever you have noted it down, please tell.
Okay, sir. So we can continue.
Okay, good. So now let's see the use of this idea. So let's say if we have, right, so let's say if we have some vectors like this. So let me use a different color. So let's say we have this Cartesian coordinate, and then we have three vectors, right? So we have, let's say, this vector, and let's say this is A vector, right? OA. This point is O. This is A. Its magnitude is, let's say, 3, and it is making an angle, let's say, 30 degree. And then we have another vector, let's say OB. This is making an angle 60 degree, and this, its magnitude is, let's say, 4. And then we have another vector, and then we have another vector whose magnitude is, let's say, this one. Right, this thing is, let's say, 60 degree. Right. So this thing is 60 degree, and this is C.
Yes, sir.
So OC vector. So we have, and its magnitude is, let's say, 2. Right. So we have these three vectors, and if we want to find out the resultant, so using the parallelogram law, right? Using the parallelogram law, that would be a difficult thing. Is difficult to use. So here comes the savior, which is the resolution of vectors, right? So that saves us from this heavy calculation, right? What we can do is that we will write every vector, right? So the question is that what is the resultant, which is OA plus OB plus OC. What is this resultant, right? And we cannot find this resultant using the parallelograms law easily. So then we have to see, or we have to check the use of this resolution of vectors. So I will directly write, or you solve this thing and tell me that what is the R that you are getting. First you solve, and then we'll check whether it is correct or incorrect. Solve this thing and tell me what is the resultant.
Hello, sir. Can you hear me?
Yes, I can hear you. Yes.
Sorry, sir. I got disconnected, I guess.
No. So don't worry about those technical issues, right? So that happens. Yeah, just solve this one and tell
Yes,
me
sir.
what is the vector resultant that you are getting. Yeah, first you try this one and then you solve it. If you get
Yes.
stuck, yeah, whenever you get any answer, please tell.
Yes.
Yeah, if you get stuck, don't hesitate to tell me, right?
Oh, okay.
Yes. Did you get any answers? Let's do this together, right? So what would be OA vector? First, we have to find OA. right?
Yes.
So OA is magnitude is 3. So 3 cos 30 I hat, I will directly write, and 3 sin 30 j, right?
Yes, sir.
So this is 3 root 3 by 2 I
By
hat, and then
yes,
3 by 2 j hat.
3 by
So OA
yes,
is this. OB is what is OB? So this
yes,
is
4
4.
cos
Yes, absolutely correct. And minus I hat. And then 4
yes, sir.
sin 60 j hat. So how much is this thing? This is minus 4 by 2 I hat. And then this is 4 root 3
4
by 2 j. So we have
yes, sir.
minus 2I plus 2 root 3 j. So this is OB. What is
Yes, sir.
OC? OC is where is OC? So this is 2 cos 60 and I hat, and then plus 2 sin 60 minus j hat, right?
Yes, sir.
So this would be 2 by 2 I hat, and then minus 2 root 3 by 2 j hat. So this is I minus root 3 j hat. So what is OC then? I minus root 3 j hat. So we have got every vector, right? And
Yes,
in
sir.
the first class, we understood that using the operations on Cartesian coordinates, that is the simplest thing that we can have. So now life is simple, right? And we
Yes,
can simply find out the resultant, which is OA plus OB plus OC. So OA is 3 root 3 by 2 I hat plus 3 by 2 j hat minus 2 I hat plus 2 root 3 j hat minus 2 I O. So minus, not minus, but we have plus I hat minus root 3 j hat. So what would be this thing? So 3 root 3 by 2 and minus 2I plus I. So minus 1. Right. This is I hat and plus 3 by 2 and 2 root 3 minus root 3. So that is root 3 j hat. So this is the resultant, right?
yes, sir.
So this would be the answer. Where did you get stuck?
Oh, I was not stuck, sir. I was just being
Oh,
slow.
you were solving. Oh, you were solving. Okay, sorry. So yeah, quickly note down the whatever the remaining part is, right? And then
Yes,
yeah, so this would be really helpful in because force is a vector quantity, so that will right. So in that force, we will use the idea of this vector addition, right? So in that
yes, sir.
sense, we can yeah, this thing is really helpful.
Yes, sir.
Yeah, note this thing down, and then we will talk about the product of the vectors. So this completes the addition subtraction. Now we will talk about the product of the vectors.
Can you repeat again, sir? I think I got lost.
Yeah. So I'm saying that we have so far talked about the addition subtraction, right? So now we will talk about the product of the vectors, right? But before we do that, please note this thing down.
So we can continue.
Okay. So now let us understand about the product of the vectors, right? So there are two scenarios,
Yes, sir.
right? There are two scenarios. So if we multiply two vectors, right? We multiply two vectors, let's say A, and this is star, right? B, this is multiplication operator. And we get a number, right? We get a number, or this is also called a scalar. Number is a scalar, right? So this is called the scalar product. And this is also called the dot product. So this operation is denoted by dot. So this is generally represented as A dot B, right? And then we multiply two vectors, right? And then we get
Yes.
another vector. We get another vector, right? So this is called the vector product, or this is also called a cross product. So we will understand these things one by one, right? And this is represented as A cross B. This is represented as A dot B, right? So this is used in different situations. So what? Used in different situations. So when we will talk about the potentials, work done, and all those things, so we will talk about the scalar product. When we will talk about the torque and angular momentum and all those things, so then we'll talk about this cross product. So these two vector products have different use. So first, let us understand about the scalar product, or this is also called the dot product.
Yes, sir.
So this is written as A dot B, and it is given by AB cos theta. Right. So this is given by AB cos theta. And if we want to find out, right? So if we want to find out what would be I dot I. So I dot I would be magnitude of I, and then magnitude of I, right? And then we have cos of, what would be the angle between I and I? What would be the angle between I hat and then I hat? What is the angle?
I'm not sure, sir.
Okay, so you have I hat in this direction, and then I hat again. So what is the angle that you're seeing? 0, right? Right?
Yes, sir. Zero.
So, and what is the angle between I and J?
Yes, sir.
What is the angle between I and J? That is 90, right?
It's
And then, yeah, and then you have the angle between I and K. So that is also 90, and then G and K, that is also 90. So all these things are mutually perpendicular, right? I, J, K are perpendicular. So I and I, they have the angle between them 0 degree. So magnitude of I, what is the magnitude of Y? Let me see if you remember the idea of this I hat or not. What was the magnitude of I hat? Let me write it in this way. Yeah, what was the magnitude of I hat? What were I, J, and K's? What were I, J, and K's? Can you tell me?
X, Y, and Z.
Yeah, so they were something in X, Y, and Z, right?
Um,
That was the crucial thing, right?
it was
I, G, and K, they
was the
were
direct.
unit vectors. Yeah, they were directions in X, Y, and Z direction, and they were unit vectors. Unit vectors means that their magnitude was 1. So its magnitude is 1. Its magnitude is 1, cos 0 is 1.
I
So,
is X.
yeah, so I hat is unit vector in X direction. So if I move 1 unit in X direction, that is I hat, right? So I have this X direction. If you move 1 unit, so that is I hat. If I move 2 units, so that is 2 I hat. If I move 3 units, so that is 3 I hat, right? And then I have J. So 1 unit in Y direction, that is J, and then 2J. So something like this one, right? Yeah, so they are unit vectors in different directions, right? So this thing would be 1. So we got that I dot I, that would be 1. Clear? Is it clear?
Yes, sir.
And if I want to find out what would be I dot J hat. So magnitude of I, magnitude of J, and what is the angle between them? From this definition, what is the angle between I and
90.
J? 90 degree. So magnitude of I is 1, J is 1, cos 90. How much is this thing? Cos 90, boss. Cos 90 is 0, right? Cos 0 is 1, cos 90 is 0. So whole thing would be 0.
Oh, yes,
So I dot J, this would be 0. Similarly, if I want to find out J dot K, that would be 0 because again the angle is 90. I dot K, that would be 0 because again angle is 90. And similarly J dot J, that would be 1, and K dot K, that would be 1. So if I take this thing, I have to remember that whenever I take the dot product with itself, right? I dot I, so only I dot I, J dot J, K dot K, that will survive only, right? So if I have,
yes, sir.
yeah, if I have the vectors, let's say A vector, which is AXI plus AYJ plus AZK. And I have B vector, which is BX, which is BXI and BYJ and BZK. And I want to find the dot product between these two. So one way to find out the dot product is this thing. AB cos theta, magnitude of A, magnitude of B, the angle between them, right? So here theta is angle between A and B, right? So if I want to find out A dot B, right, then one
Yes, sir.
way is to just find out what is A magnitude, B, and the angle between. Other way is using the I dot I relation. So I already know that only I dot I, J dot J, K dot K will survive. The rest will become zero. So I have AXI dot BYJ. That will cancel out, right? So if I write this thing, AXI, and that is dot product with BXI, BYJ, BZK. I will not write every term, right? So
Yes, sir.
let me just write the only the I and I part. So this would be simply AX, BX plus AY, BY plus AZ, BZ. So only I dot I will survive, right? Is this part clear?
Yes, sir. Yes, sir.
Okay, so please note down from here, and we will continue from there, right? So please
Yes, sir.
note down this part. And this would be the last topic from vectors. And then we will, so then we will hop on to whatever we were doing in the electric charge and field. So these things were used necessary to recap. So yeah, these things we will use in the subsequent topics. So that's why we recapped these things.
Yes, sir.
So whenever you have noted and whenever you want to scroll down the screen, please tell.
Okay.
So these are equals, right? This is,
Yes, sir. You can scroll down, sir.
yeah, whenever you have noted it down, please tell.
Okay.
Done.
Yes, sir.
Okay, so if it is done, then let's do some question and let's understand this that how much you remember, right? So A is given as 3I plus 4J plus 2K, and then B is 5I minus 3J plus 4K. So find out A dot B. Please find A dot B and tell me what is the answer you are getting. Please find out A dot B and tell me what is the answer you are getting.
Okay, sir.
Yes. What is the answer that you got?
8i 1j 16.
Remember, this is the dot product. So your answer would be vector or a scalar. What would be your answer?
For 1 minute.
So your answer would be a number, right? Your answer would
Yes,
be a
sir.
number. Please
So I'll
check.
do it another.
Yes, please do it again. Because this thing is very important. This thing is very, very important.
Yes, sir.
The answer is
11, sir.
11. Yes. So the answer is on the top, right? So
Yes.
you have to just A dot B is simply 3 into 5 plus 4 into minus 3 and then 2 into 4. Right. So this is 15 minus 12 plus 8. So how much is this thing? That is 23 minus 12. So then it is 11. Yes. So why were you getting those I and other things? That is simply AX, BX, AY, BY, AZ, BZ. That is the answer, right?
Yes, sir.
Good. Good. Your answer is correct. So yes, good. So this would be the answer. Now, there is another way we have to use this dot product, right? And
Yes.
what is that? So the question is that two vectors whose magnitudes are 3 and 4 respectively have the angle. So the angle between them is 60 degree. Find the dot product of these vectors. So this question vectors. So then this answer is very simple, right? How we can solve this thing? So we have A magnitude, which is 3. We have B, which is 4. Theta is given. So we have to use the first definition of the dot product. General definition of the dot product. And that is A dot B. B we know 4 and cos of 60. Cos of 60 is half. So this would be simply 6. Right. So we have found out the dot product in a different way. So quickly note this thing down and then we'll talk about cross product. So only this much we will need, right? This dot product is used to calculate the angles between the vectors. So that is the use application of the dot products, but we will not go into detail, right? We will, yeah, so that much we will not need. Now, after that, I will talk about cross product.
Okay, sir.
Yeah, whenever you have noted it down, please tell.
Yes, sir. We can continue.
Yes, sorry, I got disconnected somehow. So,
Yes, sir.
yeah, I got disconnected. Okay, so did you note down this part? Let me share this thing again. So, did you note down this thing?
Yes, sir.
No, you have noted.
Yes, sir.
Okay, so now let us understand the other product of the vectors, that is the cross product, right? So this part is very, very crucial. And this is also called vector product.
Yes, sir.
So we multiply two vectors and then we will get another vector whose magnitude. So this part is the magnitude of this A cross B. And then we have this direction in hat. So how do we determine this direction? Right. So n hat is determined using the idea of Maxwell's right hand thumb rule.
Yes.
Right. So from using this thing, we get the direction of n hat. So let's say, first let us understand this, that how do we get this n hat? So let's say we have this vector a hat or a vector, and I have this vector b in this same plane. So on this screen, which means that this is in the same plane. And then I want to find out the A cross B direction. I'm only talking about direction, right? So n hat I'm talking about. Okay. So to get the direction of this thing, what I will do is that I have two vectors, right? So let me show you this. So okay. Yeah. So I have two vectors, right? I have this vector in this direction and I have this vector. So this is in the other direction. This is B, this is A hat. So if I want to find out A cross B, A cross B. So what I will do is that this is my palm, right? And I will, this is my thumb. So I will put my palm in the direction of A hat, right? In the direction of A vector. And my fingertips are pointing towards this A vector direction, right?
Yes, sir.
And I will cross my palm in the direction of B. So whatever the direction my thumb is pointing out. So I will put this thing like this. I will cross this thing. So my thumb is pointing some direction. Whatever my thumb is pointing, whatever the direction my thumb is pointing out, so that would be the direction of A cross B. So that is the idea of Maxwell's thumb rule. Is it clear?
Yes, sir.
Yeah. So can you tell me what would be the direction of A cross B? Will it be coming outwards or going inwards? Outward or inwards?
It's outwards.
It's outwards. Absolutely correct. So it's outwards, right? So outward direction is represented by this dot. And if I have this cross, so cross represents inward direction and this dot represents outward direction.
Yes, sir.
Right, one moment.
Okay.
Yes, so this would be outwards and inward, right? And how we can memorize this thing? So outward direction, let's say we have this arrow, right? We have this arrow, and this is the tip of the arrow. So if this arrow will come towards you, right? Then what would be the thing that you will see? What would be the thing that you will see? Will you see this dot or will you see this cross? If the arrow is coming towards you, what you will see?
It's cross.
Okay, so you will see the cross. And let's say the arrow is going away from you, right? So you will see the dot or cross.
It's dot.
Dot. Okay, so let me just show you this thing, right? So let's say this is my arrow, right?
Yes.
And I don't have the feathers behind. So I don't have that those feathers, but let's say this is the arrow. And let's say if this
Yes.
is coming towards you, so what is the thing that you will see? You will see the dot, point, right? You will not see the cross. So
Yes,
if
sir.
it is coming towards you, you will see the dot. Clear?
Yes, sir.
And if it is going away from you, so then you will see this cross, right? If it is
Yes, sir.
going away from you, so you will see this cross. If it is coming towards you, you will see this dot, right? So
Yes,
that is
sir.
how we memorize these things. So this is the dot which is outwards coming towards you, that is outwards. This is cross which is going away from you, so that is inwards. So A cross B in here, that would be dot, as we have said, outwards. This is the direction. And we have to always remember that A cross B is always perpendicular. So A cross B, this is to note, A cross B is always perpendicular to A vector and B vector, right?
Yes, sir.
So this is how you find out the direction. And this direction is very important because cross product is vector product. So this was the idea of A cross B. And if I want to ask you, what would be I cross J? Can you tell me what would be I cross J? What would be I cross J? So let's say I cross J is magnitude of I, magnitude of J, sine angle between them, and then n hat. So find out what would be these things. Tell me what would be these things. Yes, got any idea?
No, sir.
Okay, so magnitude of I, that is 1. Magnitude of j, that is 1. What is the angle between I and j? 90. So that is also 1. So you have 1. What about n hat? What about the direction? So you have I, you have j, and if you if you use the Maxwell's thumb rule, what would be the direction that you will get? Right, so let me show you this thing. Okay, so what is IJK, right? This is my IJK. So this is right. If I can show it properly, so this is my IJK. So this is I. This is right. This is J, and this is K. So all these things are what? Mutually perpendicular, right? Can you see it? So all these things are mutually perpendicular. So this is I hat x direction. This is okay. So I have to no. So if this is going towards you, right? So this should be. So let me make it this way, because yeah, upward. I will assume that that is upward is y, right? So in that way, it will be useful. So let's say this is x. This is y. Upward is y, and then coming outwards, right? Coming outwards, that would be my z. Is it clear?
Yes, sir.
So if you curl your, if this is your x, I hat, this is your I hat. You want to find out what is I cross j. So you will put your fingertips in the direction of x direction. You will curl your fingers in y direction. What is the direction that you are getting? What is the direction that you are getting? If you do this thing, what is the direction that you are getting? All these things are perpendicular, right? So what is the direction that you will get? If you have this is your eye. If you curl this thing, so what is the direction your thumb is pointing out? See, what is the direction thumb is pointing out?
It's outwards.
Outwards. So that is Z direction, right?
Yes, sir.
That is Z direction. What is the Z direction? Can you tell me? What is the Z direction? Z, K hat.
Yes, sir.
So this would be K hat. So remember, if I want to find out I cross K, J, so that would be K hat, right? Similarly, if I want to find out J cross K, that would be I hat. And to understand these things, I have to use this nice trick, which is called the cyclic property. So this is I, this is J, this is K. And if I take I cross J, I will get K. If I take K cross I will get J. And if I take J cross K, I will get I. So this would be positive. But if I do it reverse, right?
Yes, sir.
So if I want to find out I cross K, so that would be minus J. So if I am going clockwise is positive, anti-clockwise, that is negative. So is it clear? So if I want to find out, please tell me, what would be J cross I? What would be J cross I? So you are going clockwise or anti-clockwise? J cross I, anti-clockwise, so that would be negative. So J cross I, that would be minus K hat. Clear? Yeah, so these things we have to remember. So please note it down, right? But let me just, yeah, so let me just talk about the last thing. which is that if you have this AXI vector, AYJ vector, and AZK hat, and you have B vector, which is BXI, BYJ, and BZK. Right. Then what would be A cross B? You know already what is A dot B, but A cross B would be what? So this is used. So we use the determinant formalism to find out what is the cross product. So this is the determinant of this matrix, right? So we have to find out the determinant of this thing. So have you studied the matrix formalism in your have you studied matrix determinant and matrix?
No, sir.
Yes, you have not studied that.
No, sir, I don't think so.
Okay, so then let me just tell you that the determinant of this thing would be simply, so if I want to find out I, so I will just take this I hat, and if I'm taking this, so I will ignore this row, I will ignore this column, and I will multiply this thing diagonally. Is it clear?
Yes, sir.
So this would be AY BZ minus AZ BY. And then I will take the negative sign, negative of J hat, and then I will ignore the J column, J row, right? So I will ignore these things. So what I will find? I will ignore this thing, I will ignore this thing. So what I will get? What I will get? Then I have to multiply these two things, right? So I'll have to multiply this one and this one. So this would be AX BZ minus AZ BX. Is it clear?
Yes, sir.
And then K hat. So K hat, I will ignore this thing, K column and K row. And what is the remaining thing? Then I have this one is the remaining thing. This one and this one. So this is AX BY minus AYBX. So this is the determinant formulas. We will do some questions. So we'll when we'll do some question, then this would become easy to understand. But yeah, you note down this part. So you please note down from here.
Okay.
Okay, so this would be enough for the vector portion, right? So this much recap we will need in electric charges and fields. Yeah, whenever you want me to scroll down the screen, please tell.
Yes, sir, you can scroll down.
So just note down this part. Yeah, so this has become a mess, but yeah, we will do some questions and this would become easy to understand. So we'll do some questions. Yeah, whenever you have noted, please tell.
Yes.
Yeah, whenever you have noted, please tell.
Yes, done.
Done. Okay, so then let us do one question and then it would be easy to understand. So let's say, oh, so let's say we have a vector which is 3i minus 2j plus 4k, and then we have 2i plus 3j minus 2k. And then we want to find out what is A cross B. So we will use the determinant method, right? So A cross B would be, what this would be I, J, and K. And then I have 3 minus 2, 4. And then this is 2, 3 minus 2. Right. So first I will ignore this and this. Right. So I will write I hat. And what is the thing that I have to multiply? This with this. So minus 2 into minus 2 minus 4 into 3. Clear?
Yes, sir.
So, and then I will take J part. So this is taken with minus sign. I take this thing, I ignore this part, I ignore this part. So what is remaining? This one and this one. So 3 minus 2 minus of 4 into 2. Right? J is
Yes, sir.
done. And then I have K. So plus K hat, and this is what? This is, I have to ignore K and this one. So these are the things which are remaining, right? So 3 into 3 minus of minus 2 into 2. So what would be this thing? So this is minus 2, that is 4, and minus 12. And then I have minus j, minus 6, and minus 8. And then I have k, 9 minus and minus plus 4. So how much is this thing? So this would be 4 minus 12 is minus 8 I hat. This is minus 14 and minus, that would become 14 j hat. And then this is 13 k hat. So this is A cross B. Is it clear?
Yes, sir.
So quickly note this thing down, and we'll do we'll do some question in the next class, and this will become clear.
Yes, sir.